Welcome to statistics. So we're going to have a look at all of these different tests. We're going to start off today with standard deviation. Like I said before, if you are confident with your maths, then you can, I'm fine, that was just a tickle, then you can just move on at your own pace. Okay, you need to get the statistics done in about 5 lessons. The t-test. So that noise is my dog. I have wooden floors. Anyway, the t-test takes 2 lessons because there's 2 different types of t-test. Okay, so first of all, please have a look at my very funny joke on this PowerPoint. I am going to attempt to try and write on these slides. I don't actually have a pen to use this, I'm just using my finger, so it will be quite scruffy. Very sorry. All right, let's move on. So the first thing to notice is that you will be given the formula, which of course you already know because you have read your specification, where it tells you there is a section, a whole maths section towards the end of your specification, and it tells you exactly what you will and will not be given and what they expect you to be able to do. But certainly for this whole booklet, you will be given everything we're going to do, including standard deviation. So why do we need statistics at all? Why do we need to do anything? Well, as you can see, I think this diagram very nicely shows it. Data can get very messy. Now, when you're working in a lab, you do 3 repeats at the most. Out in the field, in a clinical trial, you can be doing hundreds of thousands of bits of data, and you can also be gathering data over many years. There's a study on predator-prey relationships that they've looked at in North America that's been going for 100 years. That's a lot of data. So you need some way, actually it's over 100 years, so you need some way of putting it together, sorting it so that you can compare it. Compare one group to another, compare one year to another, compare one region to another. So we need to work this stuff out. So first of all, something that the exam board will expect you to already know how to do are all of your averages. Now this is why you cannot use the word average when you mean mean, because mean, mode and median are all types of average. So you have to be specific. Hopefully you've already noticed in biology, you have to be incredibly specific in your language. So please make sure you know how to work out mean, mode and median, and you are using the word mean correctly. So here's an example, a nice little one, 10, 11, 11, 12, 14, 15, 16. The mean, remember with means, you can have decimal places even if you are talking about whole organisms. You can't have half a person, but you can have 0.5 of a person in a mean. So the median, the mode, the range there, we're going to talk about a bit more about range as well. So the median is the one that is in the middle when you arrange them in order. If you have 2 that are in the middle, so if you have an even number of numbers and you have 2 in the middle, you take the mean of those 2 numbers. The mode is the one that comes up most frequently, and the mean, you add them all together and divide by how many bits of data that you have. So you would add together 10, 11, 11, 12, 14, 15, and 16, and divide by 1, 2, 3, 4, 5, 6, 7. Divide by 7 because you've got 7 numbers. The median there you can see is 12. It's the one that's in the middle when you've arranged them all in order, and 11 is coming up more frequently. There's 2 of those. So make sure you know how to do those, because they could very easily ask you that. And we're going to have a look at normal distribution in a minute, where the mean, the median and the mode are always round about the same. Right, so types of statistic. We're going to have a look at standard deviation today. Standard deviation is a descriptive statistic. You shouldn't use the word significant. So when we talk about there being a significant difference, you can't use the word significant when you're doing standard deviation. You can use the word significant for all other statistical tests that we're going to have a look at. So standard deviation is a statistical test but that you can't assign significance to it. You can just show values. And the same with range. Range is not all that useful. Right, so we're going to have a look at standard deviation today and range, and then we're going to move on to the inferential tests. So the inferential tests allow you to use the word significant, because you can say that one is excuse me, different to that other group. You can say these two areas are different. You can say these two regions of the country are different. There is significant difference, or there is not significant difference. You can use that word for Spearman's rank. The two different types of t-test we're going to look at, paired and unpaired, and then chi-square, I don't care how you say it. Mrs. Thomas always used to say chi-square. I always say chi-square, doesn't matter. We're going to have a look at chi-square again, this time next year. The year 13s, it was in their penultimate topic. So we'll do that probably February of next year. It relates quite nicely to the inheritance topic, the whole genetic crosses, Mendel, all of that stuff next year. Now this slide, skip it if you are not a psychology student or a maths student. They need to know which ones are parametric and which ones are non-parametric. Parametric tests show a normal distribution curve. So they kind of, see if I can do this, they kind of go like that. That is a normal distribution. Okay, so that's what our tests, the only parametric one we do is t-test. The non-parametric ones, Spearman's rank and chi-square. Chi-square, if you think about it, inheritance, you have certain phenotypes, so it's much more categoric data. So it's kind of more qualitative data. Standard deviation, parametric data forms this nice kind of curve because you have lots of variance. Chi-square, inheritance, you get certain discrete phenotypes, it's qualitative data. Standard curves like this, normal distribution, is for quantitative data. Okay, right, so why do we want to be able to compare things at all? Well, if you're comparing a drug, you want to have a look at the drug compared to the placebo. You want to know that there is a significant difference, otherwise what's the point? Also, when you develop a new drug, you always test it against the old drug. There is no point putting a drug through clinical trials, millions of pounds worth of investment, if it is not going to be significantly better than the drug that is already available. Many companies release a drug and then try to release a better one. HIV therapies, they're constantly trying to come up with improvements, with new ones, but you're not going to put it into clinical trials if it's not significantly different, significantly better than what already exists. It's used a lot in all areas of biology. So conservation, you want to know the measures that we're putting into place, the conservation that we're doing, is it having a beneficial effect? Is it making a significant difference? You're paying people, you're investing in these different techniques, you want to make sure that it works. So we have things called stakeholders. Stakeholders are the people that are somehow invested in the project. That might be people that have put up the money, it might be people running the project, it might be the local community. So they all want to know, is it actually worthwhile? So let's have a look at standard deviation then. So we're going to have a look at how we use it, we're going to have a look at the equation, and I'm going to tell you something that's very, very, very important as far as the exam is concerned, because you must show you're working. And I'll tell you what we mean by that when we get to one of the slides. So standard deviation is how spread your data is. It's the variation around the mean, and that's very important, around the mean. So you must have a mean first. You must calculate the mean first. Now this is how it's noted. I will kind of use that one because I can't be bothered to write the other ones when I'm typing them into a PowerPoint. But you will see all of them, and you will see them at different points. See, that's my dog padding around again because my daughter's just walked in. People keep interrupting me, very sorry.
Sorry. Enjoy standard deviation.
Right. So the greater the value for standard deviation, the greater the spread of your data. So if we looked at the height of people in your class, standard deviation would probably be reasonably small because you all fall within certain range. If we looked at it across students in the school, you've got much more variation. You've got some tiny little teeny pocket-sized year 7s. So it's about how much variation you have. Now you could use the range. The range would show you the variation, but it doesn't show you, and we're going to have a look at that as well. It doesn't give you the true spread. So it doesn't show you how varied the data is. Range will just show you the very smallest, the very highest. It won't show you what's in between. Whereas standard deviation, it gives you a number that tells you about the variation, how consistent or inconsistent your data is, how much variation there is. Yep, I just said that. Now we're going to have a look at what we mean by one standard deviation. Most of the time you want to know where most of the data lies. Now most of the data lies within plus or minus one standard deviation. Now what does that mean? You work out the mean, you work out a value for standard deviation, you add the number for standard deviation to your mean, and that will give you plus one standard deviation. You take it away from your mean to get minus one standard deviation, and so you end up with two values, which is plus and minus one standard deviation from the mean. We'll kind of come onto it and we'll have a look at that in a minute as well. Now, doctors use this a lot. If you go and have a blood test and they say it's normal, it means you have fallen within plus or minus one standard deviation. You've fallen within what the majority of the population lie in. Now, for certain things, different things in biology require different numbers of standard deviation. So plus or minus 1, plus or minus 2. And we're going to have a look at that a little bit more closely as well. Now, there are always, I've called them weird people, there are always outliers. Even if the majority fall within 99%, you are always going to have outliers. There's always going to be organisms, individuals, people, which are way greater, way lower. It doesn't mean that they're not, you know, it's normal for them. Everybody has their own normal, which is kind of one of the problems with doctors' kind of blood tests. You have to go with the majority, but sometimes if you have an underlying condition, that's where they monitor you over a long time, because they work out what your normal is. Anyway, I digress. Right, so standard deviation or range, I touched on this earlier. So if you look at both sets of these, they have the same range. They are both 1 to 4. The lowest is 1, the highest is 4. But if you look at this top one, oh, that wasn't very well underlined. There is much more consistency with that. Much more consistency. So if you worked out the standard deviation for this group, which would have a much lower standard deviation, and this group would have a much higher standard deviation. So it doesn't show you, just looking at the range, doesn't show you the variation in your data, which is why we work with standard deviation and we don't work with range very often. Okay, like all the colour selection, very nice. Right, so you can see this nicely. We've got two normal distribution curves here. These two curves have the same mean, mode and median. So that's not very helpful. But if you calculate the standard deviation, this one is going to have a much higher standard deviation than the other one, because you can see there's much more variation in that mean, around that mean, I should say. Okay? Right, so this is what I mean by standard deviation. Now, if you calculate the mean is, can I draw this here? That's the mean. You then work out what the value for standard deviation is. Now, it doesn't matter whether it's plus or minus, the standard deviation value is the same. If you do standard deviation plus the mean, it will give you the edge of that red there. If you do standard deviation minus the mean, it will give you that value there. This is very difficult to do with my finger, I'm very sorry. So you get your mean value, you add the standard deviation value to that mean to get this one here, and you take that mean number and you take away the standard deviation to get this one here. So this represents plus and minus 1 standard deviation. Now, in terms of the population, 68% of your population should fall in that range there. 68% of them. Okay? And it's the same on this one. It's a much smaller standard deviation, but 68% of the population fall within that range. Plus or minus, plus and minus 1 standard deviation value. So it's the mean plus the standard deviation value, the mean minus the standard deviation value, and that is plus or minus 1 standard deviation. So we write it as plus or minus 1 standard deviation. Okay, right, so you can see here you've got plus or minus 1 standard deviation here. I need a different colour. Here you've got plus or minus 2 standard deviations. Now 95% of your individuals should fall within that range. So how do you work it out? You take your mean, you add 2 standard deviation values, and then you do the mean minus 2 standard deviation values. So if your standard deviation was 5, the first one would be plus 10. If the standard deviation is 5, the second one will be minus 10. So plus or minus 10 either side of the mean. And then this last one is plus or minus 3 standard deviations. Now 99.7% of your population should be within that range, plus and minus 3 standard deviations. So you can see there's very little outside of that if it is following a normal distribution. If it doesn't follow a normal distribution, then you can get all kinds of things. Okay? Right, so this is the standard deviation equation. We're going to have a look at it slowly. If you're not a mathematician, you might go, what on earth? But let's have a look at it. Now, this little thing comes up quite frequently. It's kind of like a backwards 3 thing, or it looks like a big E. And it means you add up anything that comes after it. Now you can see here, let me see if I can highlight this. The only things you're adding up are these, what comes after it. So you're adding up these. Now those are the value minus the mean value. So if your value is 10 and your mean is 9, it would be 10 minus 9. That's the bit in the brackets. And then what do you do to those? You square them. Okay? Now that's just one value. You've got to do that for every single value that you have in your sample. So let's just quickly do some numbers. I'm going to have 10, 11 and 12 and 8. Oh, I can't work out these things. Let's have 9. Yeah, so let's just get rid of this for a minute. So for this, so what's the mean of that? 9, 10, 11, 12. So the mean is 10. Ugh, God, honestly. So you would have, let's take the value, first value, 10 minus 10 squared plus, because this means add it all together, plus then the next value, 11, minus the mean, which we said was 10, and then square that, plus then the next one, 12 minus 9 squared, and then I'm running out of space, plus, and then 9 minus 9 squared. So what you would do is just type all of that into your calculator. Just type it all in. Don't work out all of these individually. Just type it all into calculator. If you don't know how to do that in your calculator, then you're going to have to ask somebody. Google has some if you just Google how to type this into your calculator, they're very, very good. Because honestly, I bought a scientific calculator a couple of years ago. I had no idea how to use it. So if you Google it, it usually comes with a little sheet on how to do things. Otherwise, I don't know, first time friend, I'm sure they can tell you. So you work out that top row. So you've done this. Let me try and. So you've done all of this. That gives you this top row. And then what you need to do is divide that by n minus 1. Now n is how many numbers you have. So I have 1, 2, 3, 4 numbers. So n minus 1 would be 3. So you add up all of that top row and you divide it by 3. And that will give you a value that I am going to call y, just to not use any letters that have already been. Now this is the important thing, and it's the step everybody forgets to do. You square root all of this stuff. You've worked all of this stuff out. You then have to square root it, and that will give you your final standard deviation value. Okay? Right, I'm sorry for that mess. So let's have a little look. So this will help you to understand deviation a little bit more. So we have a wingspan of a moth, and we're going to have a look at it in centimetres. And so the wingspans are, oh look at that, almost the same as my example, 10, 11, 12, 13 and 14. So what is the standard deviation? Well, first of all, you have to find the mean. The mean for this is 12. It's the one that's kind of in the middle of that. Even I can do that maths. And so then you need to show you're working out. Now, this is showing you're working out, but you can see in these brackets, they've already calculated x minus the mean. Now you can just write out x minus mean. So you could do 10 minus 12 squared. So that's a rubbish 2. So this would be the same as that. Okay? So I've just done it kind of longhand, they've done it slightly shorthand. I would just stick to this way. So write that up. So this is what we mean by showing your workings. Okay? But then you just plug all of that into calculator. Just stick it all into your calculator, and what you should get is something like that. Now again, oh, you mathematicians like to stick with your fractions. Please, please, please just take it down to an actual number. Okay, so we've got 1.58 for this set of data. Okay, remember that, 1.58. So the wingspan of this moth, 70, 71, 72, 73, 74. Now I can already tell you what the standard deviation for that is. So pause this video, have a little think. Can you work out the standard deviation for that? So have a little pause. Right, if you've come back, the standard deviation is the same as the last one. It's 1.58. How do I know that? Because the variation is the same. The variation is exactly the same. So there you go, I was right. And that's because the last set of values were 10, 11, 12, 13 and 14. So there were 10, that's rubbish, 11, 12, 13 and 14. So the variation, let's have that. Oops. The variation here is the same. Look, 0, 0, 1, 1, etc. So this is what we mean about the actual values doesn't really matter. It's showing you how much variation there is. Okay, so let's have a look at the next one, see if you can guess what the standard deviation is going to be before I show you the answer. So the standard deviation for this one, 10 to 14, 70 to 74 is 1.58. So what is going to be the standard deviation for this one? Pause, have a think to yourself. Right, if you've come back, did you guess that the standard deviation is going to be double? Because the last set went from 0 to 4. This set goes from, oh, I've got to keep doing that, from 0 to 8. So it's going to be double the standard deviation. You've got twice as much variation. So yep, there you go. Okay, cool. Right, so this is a worked example. So to be honest, it's probably worth you just going through this in your own time so you can see the values up here. So the number of samples, sorry. So you've got 10 samples, they are your values. So you've got to plug it in to this thing. So again, you've got to work out all of, well, you've got to write out all of those first. So whatever the mean is, it would be 28 minus the mean squared plus 30 minus the mean squared plus 17 minus the mean squared plus 31 minus the mean squared, etc. That would be over n minus 1. So you've got 10 samples, so it's going to be divided by 9. And then don't forget to square root the whole answer. Okay, so work through that in your own time. And here's the answers for you. Now, plotting standard deviation on a graph, you plot one standard deviation above the mean and one standard deviation below the mean. So let's, can I work out what the standard deviation is on this? So let's say the standard deviation is 5. So you're plotting the mean here. This bar represents one standard deviation above the mean, so that's 5 above, and this represents 5 below. So that represents 10 if your standard deviation was 5. Okay, does that make sense? And that shows you the variation between your means. Now, a good thing to note is if your bars overlap, then it means some of the values in this bar are also in this bar, and so they wouldn't be different. So if that was, I don't know, 2 fields and you were looking at how many daisies there were, there aren't different numbers, there aren't different enough numbers of different daisies in each of those fields. Okay, if the standard deviation bars don't overlap, these were some bars, then that means these two groups are different. Okay, cool. Right. This just recaps. 68% of your data should lie within plus or minus 1 standard deviation. 95 is plus or minus 2. Anything out of that, for us, can be considered anomalous. Now, if you are looking at kind of drug trials, things like that, they work to much, much, much higher levels, and you actually use different statistical tests. But yeah, so there you go. Most of the time, we're happy with 95% because it's biology and things do vary because it's natural systems. Okay. Right. So if standard deviation is large, what do we do if it's large? Well, depends on what you are looking for, most definitely. Can I go back to that? I can't. So it depends what you're looking for. Most of the time, if you would repeat, you would probably look at it. Do you have a large enough sample? Because that's definitely going to impact your standard deviation. The smaller the population, the larger your standard deviation usually, because outliers have a much bigger effect. So you would probably use more data, and you would probably want to repeat just to make sure that it kind of is. Now, if there is a very large standard deviation and you've repeated and you've got a big enough sample, then it means your populations are different, and that might be what you're looking for. If you're looking for more consistency, then it means something's gone wrong. You haven't designed your study properly, or there just simply is too much variation, and you're going to want to have a look at why there's so much variation. Okay, right, so work through the questions in your book. If you get stuck, then there's that Q&A book thing, that Q&A doc, sorry, that Google Doc. You can ask any questions you like on there. Okay, thank you very much. Oh, and there's some answers on here. Sorry, let me just check that I've actually, I don't think there's any.